Good morning. Today we are going to discuss a topic on multi-criteria decision making. Now, basically, actually, we are going to discuss an algorithm to solve multi-criteria decision making problems. Now, before discussing that, let us first understand what is that are so-called multi-criteria decision making problems. I mean, what are the so-called MCDM problems, right? Now, the thing is that in MCDM, they are you'll find this MCDM word, whenever you're going to search a problem in managerial applications, in any literature, you'll find so many works have been done in this particular area. Now, you may think that, this is a strictly, this MCDM methodology or MCDM problems, a kind of, mainly only the academicians, they actually discuss algorithms or they discuss this particular problem, but, in real life case, many a times a common person or a common man, they sometimes need to, any person for that, in that sense that they need to apply any MCDM algorithm to actually take a decision. So let us now discuss what is MCDM or what are the MCDM problems. Let us just discuss in short. Now, as the name implies, multi-criteria, that means you can understand there will be a set of criteria. And suppose, think about this example, particular example, that you want to purchase a car, automobile, right? So, there are so many models available in market and there are many features, right? Like, let's say model 1, model 2, let's say you have 10 models and features like style, reliability, cost, fuel economy, its interior design, something like that, right? Now, the problem is that, you may not have a clear-cut choice here. That means you may not have a kind of, optimal model, which is, which will outperform all other models with respect to these, we have mentioned 5 attributes or 5 criteria. So you may not have a model which will actually outperform all other models or rest 9 models with respect to each of the criteria mentioned. Then it becomes very complicated to find the best model. So because and the problem is further complicated because there are some these are called attributes or criteria, right? A set of attributes or criteria, and some may be benefit attributes and some cost attributes. What do they mean? Benefit attributes mean that the attributes, like let's say this one, style. Let's say out of 10, any Likert type scale out of 10. Let's say the model 1 scores 8, maybe model 2 scores 7 out of 10. Let's say. Let us assume this. Let us for the time being, let us assume that model 1 scores model 1 scores 8 out of 10 and model 2 scores 7 out of 10, right? Now, style is a benefit attribute. That means the higher the value, better is the model. But let's say in terms of cost, lower the cost, very apparent, right? Better the alternative. So, we can understand there will be some attributes which are benefit and some of them are cost. And you may have more than 5 attributes. In real cases, you may have 20 to 30 attributes and you may have 100 such alternatives. Then our task is to rank this alternative. This is all about your typical MCDM problems. MCDM stands for multi-criteria. Now how to solve this kind of problems? Simple weighted average may not work always. Simple because, as I said, there will be some attributes which should be, a kind of cost attributes in nature. So simple weighted average may not yield you a optimal solution. So there are many algorithms to solve this kind of problems. I'll demonstrate one first. I'll demonstrate the working principle. Then we'll see how to implement that algorithm using your Microsoft Excel. Fine. So let us see that algorithm first. That algorithm is known as, it's a very famous algorithm. If you search in Google, you will find many scholarly articles, written on this algorithm. You will find PDF and PPT files. So let us just now see the working principle. So the algorithm name is Topsis. It's an abbreviated form. The full form is Technique of Order Preference by Similarity to Ideal Solution. It was originally developed by Huang and Yun back in 1981. It was originally developed by them. Then it has gone through many developments over the years. People now talk about many advanced version of this algorithm. But let us try to understand the basic principle first. Then, as I said, then we'll see how to implement that algorithm using Microsoft Excel and solve a real life problem. Okay. So now, in order to understand the working principle, let me just mathematically formulate the MCDM problems. Now, one thing is that, initially you may find that, when I'm going to write the steps, you may find that it is very difficult to understand. But ultimately, we just go through the steps for a number of times, then they become very easy, and using that Excel it will be very simple, right? So don't be, nervous. This is the kind of human nature that, whenever you see some mathematical notations, people seem to think that, this is very complicated one, but it is actually not. It's a very convenient and very simple and yet effective one. Okay? So first, let's say you have a set of alternatives. Let's say A. Let's say it has n number of alternatives. Similar to that automobile example where we discussed having 10 car models. So now for any MCDM problems, you will have also a set of criteria or attributes. Let's say, let me denote them by C. Let's say you have m such, okay, sorry, it will not be A1, it will be kind of C1, C2 up to Cm. Fine, fair enough? And out of this m criteria, let's say there are kind of let's say there are let's say there are j number of, okay, let me erase this. Let's say there are j number of attributes, j number of attributes which are, as I discussed, they are, let's say, benefit attributes. Okay, benefit attributes. And then rest m minus j number of attributes which will be your cost attributes. So we have subdivided the attributes into two clusters, set of benefit attributes and set of cost attributes. Fine. Now let me, for the notation, let me denote this m minus j by c. Okay, right? Now, so you can think of, there will be a kind of matrix-like structure, right? You know, that means A1, A2 up to AN, then C1, C2 up to Cm. This will be a matrix of, let's say, so now these, now the basically the entries or the elements of the matrix, let's say this is x11, x12, x1n, x21, x22 up to. So x22 with a score of alternative 2 with respect to criteria 2. This will be x2n and this will be xn1, xn2, xnn. Now how many alternatives you have? You have n such alternatives and n criteria. So the dimension of the matrix will be a n cross n matrix, right? It will be an n cross n matrix because you have n alternatives. So number of rows is n and number of columns is your n. Fine. This is very apparent. Now the criteria are the criteria are not, I know they may not be all equally important. Let's say, you know, that example which we were discussing, style, reliability. You know, for a particular group of user or particular segment of customers, the style may be more important than reliability. The reliability for some group of customers, reliability may be more important than style. So the criteria, you know, these attributes, they are not equally important. These, you know, the weightage of criteria 1 may be 0.2, weightage of criteria 2 may be 0.3 in this manner, right? So they may not be all equally important. So let us denote Wj, you know, as a vector or rather a 1 cross m matrix. You know, these denote the respective importance values of the attributes, right? Now, first step of the Topsis algorithm. Now we'll go into the detailed steps of the algorithm. First step of the Topsis algorithm is that you need to normalize that matrix. You know, these xij's are the elements of the matrix. Xij basically represent the score of ith alternative against the z criterion, right? Ith alternative, when ith alternative is evaluated on z attribute, you get, let us assume the score is xij. So this n cross n matrix is the original matrix which you have right now. Now the first step of the Topsis is to normalize that matrix. Now what is normalizing? Normalizing means normalizing, you know, normalize the matrix. It means, you know, you have to make sure the sum of the columns will be 1, right? So it can be done in this manner. So xij. This, no, we'll see how to do it in Excel. This is just normalizing, nothing else. Let us say you denote that matrix by, let's say, this. Now this matrix becomes Rij after normalization, right? Now let us now go to the next step. The next step is that, you know, next step is okay, let me just erase this portion. Let me go to the next step. You know, don't be worried about these steps. You know, you can just Google. You can just type Topsis in Google. You will find many articles where the elaborated version of Topsis are there. So you can just go through the steps. I'm just this for the those who are new to this particular topic, for them I'm discussing this. Now step number 2, once you have computed the normalized matrix, then you have to do, say, let's say, then you have to find the what we call that, you have to consider this criteria weightage into your computation. How you can do that? So this simple, whatever normalized version of the matrix you have got, that Rij, you multiply Rij, that is the normalized matrix which you have obtained in the earlier step, by the weight vector Wj. Okay, you will get then your weightage values are actually considered, right? So Bij is then your converted matrix. Now once you are done with that, then there's a concept in Topsis which is known as positive ideal solution and negative ideal solution. Now what do they mean? Pi, that we call them as positive ideal solution, PIS, and negative ideal solution. Okay. NIS. Positive ideal solution means if you have an alternative which will give you best score with respect to each criterion, then that particular solution is known as PIS. Now I'll explain what I have said now. So let us consider a very simple problem, then you will understand actually. Then let's say you have 3 alternatives, A1, A2, A3, C1, C2, C3. Let's say all are, this C1 is a beneficiary criterion, C2 is also benefit criterion, and C3 is a cost criterion. Let's say out of 10 scale, let's say this will give you 7, 6, let's say 4, let's say 1, 1 and 3. Let us consider this 3 by 3 matrix, then you can clearly understand A1 scores the 10 out of 10 when it is evaluated against criterion 1, and which is a benefit attribute, and C3 is the cost attribute, out of 10, so the lower the better. For cost attribute, as we discussed, lower the better, so A1 scores 2. Okay, let me just modify this section, this particular entry, let me make it 6, then it will be easier to actually understand. So now if you look at this particular alternative, then clearly find that this alternative is the best one, because A1 scores 10 against C1 8 here and 2 here, right? Now if you look at this A3, this is the worst alternative. Why? Because it scores 1 with respect to C1, 1 with respect to C2. These are basically your benefit attributes, so the higher the better, and 6 with respect to C. This should have been lower the better. Now with respect to C3, it has highest value. So you can clearly that this is the alternative which will not be suggested or recommended. This is the best. So this becomes a PIS and this becomes a NIS. Now again the problem is that in real life cases, these sort of, you may not have a problem where your alternative and criterions, the matrix may not have this kind of elements. In real life cases, you may not have an alternative which is an ideal positive solution. Because, suppose if I make this now 7, 2 and 1, then you cannot say A1 is better than A2 and A3 with respect to C3, right? Because with respect to C3, now A3 is better. So if the elements of the matrix which we discussed, if it is something like that, then your PIS practically does not exist. Can you say that same thing about NIS, negative ideal? Yes, the same thing can also be inferred for negative ideal. So, in order to find the PIS and NIS, ideally, let's say, let's say you have something like, so let's say PIS is denoted by A plus and NIS, or that may be hypothetical. This PIS may not exist in your problem, so it may, let me denote it by A plus for PIS and A minus for NIS, right? Now this can be, think of that, we had written something like Bij equals to Wj multiplied by Rij. That's what we have done. So V1 plus V2 plus, let's say up to Vj plus, and let's say here we have V1 minus V2 minus Vj minus. Now we'll see how to do that using Excel, how to find the best and how to find PIS and NIS. Once they are computed, the next step is that you have to find how far are the alternatives from the positive ideal solution and negative ideal solution. Now what do I mean by how far are they from the PIS and NIS? You make, let's say, any alternative, let's say for that problem A1 minus PIS A plus. Now you may take the Euclidean distance, in this manner. You can take the Euclidean distance. You can take any other distance measure for that purpose. So that's how we can measure the distance for a particular alternative from PIS. Similarly, you can do that for NIS as well. Now let's say let us just assume that SI plus denotes and SI minus denotes the distance of alternative I from the PIS, and SI minus is the distance of alternative I from NIS. Once they are done, then you can actually find a composite score for each alternatives. That composite score of ith alternative by this particular fraction. Sorry, this will be SI minus, SI plus and SI minus. So if you have 10 alternatives, so you will have 10 such composite scores, and you can sort them in a ascending order and you will get your ranking. Okay. Now let us see an example using this Microsoft Excel. We will implement that. We will talk about a real life example. Now you don't have to watch my face. For that matter, I don't have to also look at the camera. So kind of win-win situation for both of us. So as I said that I'll demonstrate the algorithm. I have solved a particular MCDM problem. Now this problem is actually, now you can see there are 10 alternatives A1. I'll tell what they are. And there are a few attributes like distance, adjacency, shape ratio, flexibility, accessibility and maintenance. Now this is a particular problem in the area of facility layout and design. Those who are actually familiar with this facility, or those who are from operations management, but actually let me just explain this. There are, let's say, 10 such layouts which have been designed using in software. There are many softwares are available to actually get or to design layouts. Now you need to evaluate the alternative, the designed layouts, right? So let us say there are how many? 1, 2, 3, 4, 5, 6. 6 features or 6 criteria or 6 attributes: distance, adjacency, shape ratio, flexibility and maintenance. And among these 6 attributes, this distance is a cost attribute and shape ratio is also another cost attributes, and rest 4 are benefit attributes, right? Now these A1 to A10, they are my layouts. I need to rank them, or I need to find which one is the best, or which 2 are the better than rest of the 8, something like that. So we have seen that algorithm. Now let us see how to do that. So, this data set is available to you. Okay. And for this particular problem, let us also assume one thing is that all these 6 attributes are equally important. So what does that mean? That means the weight values for these 6 attributes are 1. So the problem is very simple. Eventually it is not a big deal if you have different weight values. They can actually be computed using some other algorithms like your analytic hierarchy process, analytic network process, decision evaluation method, and trial laboratory, which is also known as DMATL. There are many algorithms which we will discuss some other sessions. Now let us just discuss this thing. Right. Now I have solved this problem, so we'll just see how to find a solution. So these values are available to you. You can just at the end of the session I will give you my mail ID. You can just drop me a mail in case you need the data set. I will give it to you. And this is just a subset of a particular, because there are more than 10 layouts available. So I have taken a subset of the data set. In any case, if you need it, you will get it from me. Just drop me a mail. I'll give you my mail ID after the demonstration. So we said that once the initial matrix is available, then our task is to normalize that matrix, right? So in Excel, you can use directly write the formula. Let's say for this, this particular cell entry H, this is just the formula is B3 to the power 2, that is B3 square. Now what is my B3? B3 is the score of A1 against distance attribute. Now similarly, your I3 is nothing but C3 square. In this manner, I have computed the square of the elements of the initial matrix. Then I have performed column-wise sum. This is the column-wise sum from H3 to H12. Similarly for I, J, K, L and M. Then I have found the square root of each of these columns, and I have divided the original matrix, that this matrix elements, by these values, right? That's what I have done. That B3 divided by H40. Okay. B3 by this particular number. Okay. Now for there will be so up to this, let me select this. This is my normalized matrix, right? Now, as we said that in this particular problem, we have assumed the weight values to be 1. They are all equally important. So that weighted matrix computation part is not required for this particular problem. However, we need to find the positive ideal solution and negative ideal solution, right? So how to find the PIS and NIS? Now, if you can recall, this Q, this is O3 is basically corresponds to the criteria distance. Now, we know distance is a cost attribute, right? So this is so in this particular column, so for cost attribute, a PIS must have values which is as low as possible, desirable, right? So in order to find the PIS component of this particular criterion, which was named as distance, I need to find PIS using that minimum of these all 10 alternatives, scores of 10 alternatives, right? So this can be found using this mean command. Those, those actually, this is very simple, And for that next attribute, that was benefit attribute, so you can write max. For that next, again, that was a cost attribute, so it will be mean, right? And raise 3, you all know that we discussed that raise 3 were, your benefit attribute. So we have taken the max values of the 10 alternatives, right? So this entire solution, this entire component is my PIS. Now NIS is just the opposite thing of PIS. So NIS, so for here I have taken mean, so for NIS it will be max. This was max in PIS, so it will be mean in NIS. So in this manner we have computed our PIS and NIS, right? So then we have actually computed that Euclidean distance measure from each alternative from the PIS and NIS. Now this is the distance from PIS. This is how far are the alternatives from the positive ideal solution, right? I mean, this is just a part of your Euclidean distance. You have just taken the square. After that, these values actually give you the Euclidean distance of respective alternatives from PIS. This is the square root, right? Once you take the sum, then you take the square root, you will get the Euclidean distance measure. Okay. Now similarly, in this manner you can find the distance from the negative ideal solution, right? The same process can be applied to find the NIS distance from respective distances from the NIS, and once you found them, the step was that it was just a ratio of distance from NIS divided by sum of distance from PIS and NIS. That's what we have computed. Now clearly, let me just type this. This was A1, A2, A3, A4, A5, A6, A7. Sorry. Okay, let me check. This was A7. What was that? Mistake? No, A7, A8. I'm not good at this. This typo happens. A10. Now you can clearly find that out of these 10 alternatives, A10 has the highest value. Right? The composite score of A10 is the highest among these 10 alternatives. So you can clearly say that A10 is the best alternative in this example. Right? Okay. So you can let me just give you my mail ID. I'll try to. Okay, now let me just write my mail ID in this particular column. So you can drop me a mail to get this data set, the entire data set. I'll provide you that Excel sheet as well. It's fri.indro@gmail.com in case you are interested to have this data set. Now I'll just conclude the session. Just be on my face for 2 more minutes, then the session will be over. So basically we have seen how to find rankings or how to evaluate alternatives when you have a set of alternatives. Now this is for a particular facility layout problem. Suppose you have offers from different universities to pursue your postgraduate or undergraduate study. Which university or college will you prefer? You can think of, in any case you may not have to apply these algorithms to find a suitable solution, but let's say some in organizations, MNCs, when they recruit some persons, kind of framework, this kind of framework may be applied. Actually, me along with the principal of my institute, Professor Dr. Topsis Choudhury, we have actually carried out a research work to rank the performance of commercial banks from both from private and public sector over the years, using some of the some criteria. We have taken 29 banks to be evaluated over the years, how their performance has changed. We have actually made a comparative study using this Topsis algorithm, and there are few more algorithms which we have also implemented. Now, so similarly, many studies can be done. This is so that study is from financial area. This is from your operations area. You can do. There are many literature available involving problems from systems, marketing, HR. Okay. So now one thing which we have considered here is that we have considered that all criteria to be equally important. Right. Now this is a kind of a vague statement now, because they are not in general. So I said there are different algorithms. Now you may ask me that how will you get the weight values? No, here we have taken this normalized matrix, find that from data sheet that we have found this, right? But in how to find, here we have considered the weight values to be equal 1. So, but in general they are not. So how to find it? For that, as I mentioned, there are other set of algorithms like AHP, analytic hierarchy process, or DMATL, ANP, analytic network process. They can be applied to find the weights, that we will discuss in some other sessions. Hope this session was helpful to you. I tried my best to make it kind of helpful to you. If you have any queries or any doubts, you can definitely can just drop me a mail. My mail ID I have mentioned somewhere. Yeah, there. In case you have any doubts, any queries, any feedbacks, all your feedbacks are welcome. With this, let me sign off. Thank you for your hearing.